Good morning, and happy Baby Friday. It's time for the O-Scope Wizard Show. I'm Gabe, the O-Scope Wizard. You have made it to the show. Thanks for joining. I really appreciate it. We have had a very exciting quest. We've been on a quest now for, well, I think it's months at this point. We started a quest way back, many weeks ago, to build a DIY, do-it-yourself, Sonos-Style Raspberry Pi Based Audio Amplifier. And we have been working on this amplifier for weeks, tirelessly, trying to quash bugs, trying to make sounds happen, trying to make beautiful lights blink. You guys have had wonderful suggestions about how to solve a bunch of different engineering problems like noise on power supplies, how to mitigate EMI, how to make sure that I'm getting enough power, different measurements to make on the different systems, how to write basic Python code, even some suggestions on how to log into a Raspberry Pi automatically. All of those have been awesome, and they have really helped build our Sonos-Style Raspberry Pi based audio amplifier. But after all that work, it does follow that we will come to the end of the quest. As wonderful as the quest is, I have really enjoyed this process. And in fact, the process has been the best part to me. The learning process, the discovery, figuring out how to build new systems, figuring out how to write new algorithms, figuring out how to make more sound for my ear holes, because I love different sounds. That means it's time to unveil the finished product. Are we ready? Are we ready? Let's see if anybody's even online to check it out. I'm not sure. I was a little bit late actually starting the stream, so I'm not sure how many people might be on. We'll find out. I don't know if very many people are on. That's okay, because it's being recorded, and you can see the unveil later on. Let's go over the best part, I think. The best part. Let's hit the drum roll. What do you think? What do you think, guys? I worked on the paint job, used some spray paint that I found, and we have an amplifier. We have a box. So this is the box we've been working with, and look, it says O-Scope Wizard now. It's got really cool colors. Got our volume knob on the front, and we've been just rocking the blank rotary encoder, and we have lights underneath it. I have epoxied in the lights, so they're sitting under epoxy. And now to turn it on, let's find out what happens when we turn this thing. Before we turn it on, let's enjoy another sip of coffee from our custom O-Scope Wizard mug. This mug is gigantic. In fact, I have many libations this morning. I have a smoothie that one of the mini O-Scope Wizards made, and then just a more classic hydration beverage of water and grape juice. I like water and grape juice. That's probably weird, but let's turn it on. So I'm going to turn it on. There's going to be a pop. In the back, I have the speakers up on. I have the speakers up on the desk today, so I can hear it a little bit better. We're going to find out what it sounds like. Oh, a little bit of a pop. And then watch. As the Raspberry Pi boots up, we're going to know when it's active, because these LEDs are going to do a cool trick. Cool tricks. I love cool tricks. Woo-wee! Cool tricks. So I added a little algorithm to basically show you when the amplifier is fully awake and ready to roll. So now when we turn the knob, you can see my LEDs illuminate. I still am rocking pink as my default color. They get brighter and darker. And if I send sound to the amplifier, we should be able to hear it. I hope. 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 Let's see if we can get some sound. Let's also make sure everything's good in the neighborhood. Looks good. So got my phone out. We're going to send some sound over to the amplifier to make sure this thing is working. Select sound, music. Select Airplay. So when I select Airplay, and let's send a song over. Here we go. Remember when we rode a three-wheeler? It was a little loud. Down to the pond. Look, our volume knob works. Our volume knob works. And you'll notice that the colors changed. Like the colors changed. So now when Airplay is active, the LEDs switch to white, and when Airplay goes inactive, they'll go back to pink. And then if I send audio from a different source, the LEDs once again change color. Let's see, I'm going to send something over from Spotify, if I can find it. Here we go. Let's send something over from Spotify. Tell it that I want to use Spotify. And now when I hit play, well, if I can get my, I'm going to run into technical difficulties as I try to disconnect. All right, disconnect. Back to pink. We're back to pink. Now let's try to connect something from Spotify. All right, Spotify says it's connected. If I hit play, boom, green, green. Green for Spotify, right? And then if I wanted to do something crazy, like, I don't know, send it via Bluetooth, let's check out what happens on the LEDs. So I'm going to connect to my amplifier with Bluetooth. Now let's send something over. Boom! Blue! Blue! That is cool. I was pretty excited about getting the LEDs to work with different colors, I will admit. But let's crack it open. So the amplifier is working. Mark 1 is done and complete. You can get sound out of it. You can connect to it. We hit all our goals, guys. We hit all our goals. We can control the volume with our volume knob, which took a disturbing amount of effort. We can connect with Bluetooth, we can connect with Airplay, and we can connect directly with Spotify. It is so cool. Let's go over some of the learnings that I had in the project. So I'm going to pull the top off and let's look inside the box. So one of the things I did was I installed little magnets in the corners of the box to help hold the box top on, which I thought was a neat idea that I've seen on some other amplifiers and other just pieces of electronic kit. Just makes it a little easier to get in and out of the box. If I move in, let's go over what's in the amplifier. I, of course, have the giant power supply, the beast, over on the left side. It is a 24 volts power supply. It'll do 12.5 amps. It is a monster. And if I look over at my desktop really quickly, I can actually see this is the power supply I bought. So this is the listing from eBay. It was $10. It cost $15.74 to get to my door. So I thought that I would write down at what everything cost, and then at the end we can tally it up and figure out, well, we're not going to really be able to figure out everything we spent on the box, but we'll be able to figure out what the components in the box cost. So our power supply was total $25.74, which, I mean, for a 24 volt power supply that does 12.5 amps, I thought, excellent deal. Excellent deal. Now let's go back to the design. Next, we have our Raspberry Pi. We have the classic. We started out with this Raspberry Pi. I managed to send it into the great Raspberry Pi Beyond through some really reckless wire wrapping while the power was on. Do not do that. But we switched over to the Raspberry Pi A. Now, why do we do that? Well, first of all, I did it because I needed a new Raspberry Pi. And secondly, the Raspberry Pi A has a better radio in it. It does fancier Bluetooth. And there's a question in the chat, what color would 5G be? I don't know, man. I don't know. I don't have an amplifier that'll do 5G. That would be next level. Next level, I'm afraid. Let's see. I think I can find where I purchased my Raspberry Pi A with a little bit of searching to figure out what I paid for it, because these things kind of get all over the place when it comes to cost. And if I can find the listing, oh, here it is. Got it. Bring it up here. Boom. Here is the listing. This was the Raspberry Pi A. It was $36.95 allegedly, with no shipping. So let's write that down. We'll write that down. We'll keep track of how much we spent on this thing, on this baby Friday. Raspberry Pi was $36.95. Now, of course, one of the questions that Mrs. Oscope Wizard asks every time I finish a project is, what if you just bought whatever it is you're trying to copy? That is a good observation she has. I once built from scratch a CNC router, and it ultimately cost a little bit more than just buying a CNC router. So you live and you learn. This is more about learning and exploring than it is about saving money. That is for sure. Okay, so Raspberry Pi is the big component. The next big component, of course, the amplifier. The guy that's making music for our ear holes. This guy, the TPA. What was it? TPA 3116D2. It is beast mode. Beast mode. Here is a listing for a very similar one. The one that I actually purchased on eBay is no longer there, but I paid $8.55 for this TPA 3116. What is it? 3116D2. And I love how the listing, and this is one of the things that confused me early on when we were doing datasheet diving. This thing says it'll do 120 watts plus 120 watts. I mean, it will not. I think my listing said it would do 150 watts plus 150 watts. It is incapable of that. But it does provide more power when you use 24 volts. So early on, we were using a 12-volt power supply to run everything, and once we looked into the data sheet, got into the details, we realized that we needed a slightly more powerful power supply, a slightly higher voltage power supply, and that is what drove us to the 24-volt power supply. Okay. Next, we used this DAC chip. This is our I2S digital to analog converter chip, which converts the digital traffic from my Raspberry Pi over to audio traffic, which then is in turn fed into my amplifier. I have a relay system, so I can have an external input and use internal audio as well. So the amplifier has an external jack. I'm still missing a right angle cord, but you know, it'll be here. It'll be here. Don't worry. That's small potatoes. You just slap a cord in here. So this is responsible for translating the sound from the Raspberry Pi into audio waveforms that my ear holes can hear. I used this chip right here, the PCM5102 I2S board, $3.91. This chip here this chip here revealed so much about power supply integrity. The integrity of the power supply. How much noise is this thing going to pick up? Well, what I'm trying to say is, if there is noise on the power supply, this little chip picked it up. When I tried to power this digital analog converter chip with my Raspberry Pi, so using the 5-volt out into my digital analog converter, it was a disaster. There were many episodes of me and you and everybody trying to find the noise. The noise was everywhere. And ultimately, what I have had to do is divide up the power that powers the Raspberry Pi. It has its own separate power supply over here. And then I have a tiny little linear power supply that actually powers the digital analog converter chip. And that leads to wonderfully quiet noise. And it is awesome. Oh man, James in the chat says, integrity is integral to integration. That feels like a tongue twister. That is a lot of I words. Let's talk about the power supplies. In fact, I mean, we've had so many episodes on the power supplies, but here is the list of power supplies that were in the mix. We had our classic, the LM2596. That is the one that had the LEDs. We pulled that out because it was a little noisy, and it's relatively large. It's almost the size of a Raspberry Pi Zero. In fact, if I put a Raspberry Pi Zero beside it, it is slightly larger than a Raspberry Pi Zero. I don't want my power supply to be bigger than my components. So then we had the MP1584. Did any of those make it in? Yes, right here. The MP15. Is that right? No. I take that back. This is the MP1584. This is the tiny itty bitty power supply that was a little bit noisy, but this little itty bitty guy can throw out 3 amps of power, which is incredible. The chat says I had so many power supply episodes, it felt like I was becoming the power supply wizard. And that almost feels true. That's a lot of power supply issues. But this little guy also only cost $1.59. So we have one of those, $1.59. Then we have the XL4015 that is this little guy. It's a little larger, but it has very quiet rails, and it is capable of 5 amps, I believe. And I am using this power supply to power both my relay, because my relay needs 5 volts, and I just did not want any chance of the Raspberry Pi noise getting into my audio signal path, so I used this guy to power my relay, and my 2 potentiometers. You'll know there was a major change. I'm just dropping that in there. We'll go over that when we get there. But yes, these in fact, of the things that I learned the most about power supplies, DC to DC converters, and potentiometers, and basically a preamplification stage. So I learned a lot about that. So this guy was $3.25. Kind of a ripoff, honestly, guys. And then here's my linear supply, the LM317 linear supply. It is very quiet, as I said, unloaded. When I'm not sharing rails with everything else, I can actually measure ripples down to 4 millivolts on a 3.3 volt rail, which is incredibly low. And it only cost $1.40, so it's my cheapest power supply. So I have $1.59, $1.40, and $3.25. Crazy, that's big money over there. So let's write down, keeping track of my different DC to DC converters. I'm gonna write it all down. $1.59, $1.40, and $3.25. Total highway robbery. Oh my goodness, it is. Wow. That is one of these things that's not like the others, and that is crazy. $3.25. Okay. Okay. So that covers the digital to analog converter and the Raspberry Pi and the amplifier. Let's talk about trying to get an external input into my system. So you can buy these boards all over eBay. They have 2 audio jacks in and then 1 out, and you use this mechanical push button to switch which audio input is going to be routed to this audio output. So I bought one of those, but of course it's really hard to automate a switch like this. So I pulled this switch off, and now I'm using a relay with a header to basically replace in a true engineering move. I replaced this tiny little elegant switch with this huge relay and a DC to DC converter and a whole bunch of wires. I mean, that is like the opposite of like thinking through it and talking through it, the opposite of awesome. But it does allow me to automate the switching of an external input or an internal audio input. Also, this guy, if I can get in here a little bit closer, I wonder if it'll focus. Right here, I was making a hole to have a mounting point so I can hold it in here. So I drilled a hole over here, and then I drilled a hole right here, thinking that there was no trace right there. Unbeknownst to me, under this white silk screen, there is a trace, and suddenly one of my channels of my amplifier did not work anymore, and I realized that I had drilled right through the copper. So I ended up scraping back the silk screen and soldering a wire there to save my board. I guess I could have just used this board, but I had already made so many modifications, and I was like, let me just make it work. So I soldered a jumper wire across there to save it. Hey man, it happens. It happens. Let's see if I can find how much this board cost. I think I can. I have it in here somewhere. Let's see. This board cost. Certainly I didn't spend $6.41 on that board. $6.41? Holy moly. Let's take a look at it, what I did. You know, you get in the flow, man, and you're just trying to make things happen. You're like, let's Let's make it happen. Oh, maybe I did not spend. Is it maybe? Oh, okay. $2.45. I purchased. I did not spend $6 and whatever on it. I purchased a couple of them at the time. Okay, I feel better. $2.45 plus $1 for shipping, so $3.45 for this audio switchboard. Audio switchboard. I wonder how much this thing ended up costing me. It's probably like I could have bought 4 just Sonos amplifiers for the amount that I paid, but $3.45 if I account for shipping. I'm trying to account for shipping. I've noticed when people do some of these wrap-up, and I'll have a real wrap-up episode that you can watch, which will be all fancy and edited and perfect. But, you know, right now we're just doing it live. Now, I have the relay that I used, which is very basic. You send an input, and if it's high, one switch is active, and if it's low, the other switch is active. Pretty straightforward. I think that this thing was $3.95. So let's check it out over here. This is the one I bought. Free shipping. And look, it got here really quickly. So this is my relay. $3.95. One of the things that I have been thinking about going forward, if I did a Mark II of this design, would be to integrate all of this into a single board, which I've talked about, and maybe not use a Raspberry Pi. Maybe use an microcontroller to make it less noisy, I think. Now, the coup de grace, the place where I spent a lot of time. Digital potentiometers. Little did I know when I removed these little 10K passive potentiometers from this amplifier board, it was going to be a wonderful learning opportunity, is what it was going to be. A wonderful learning opportunity where I spent countless hours, and I think it's 6 or 7 different potentiometers I tried. And you'll notice the last episode, I was pitching this other potentiometer. If I have it right here somewhere. Where are you? This guy. This potentiometer, the DS1881 audio logarithmic potentiometer. I was pitching it pretty hard. Had it all plugged in. You know what? It couldn't handle the audio levels coming out of my DAC. And so, one of the big things that I learned is that if you're going to drive an amplifier and it has some kind of a fixed amplification range, so like 30 dB, 60 dB, whatever amplifier range it's going to have, whatever gain it's going to gain. That's the word I'm looking for. Gain. Whatever gain it's going to have, I need to guarantee that the input level never overdrives the amplifier. That's what I need to guarantee. And what I learned by doing this project is the value of a preamplification stage. So I do not have a preamplification stage right now. I didn't understand what that was all about in an audio amplifier, really. I mean, I've used them, but you know, when you're using something and then designing something, those are two completely different animals. When you're driving a car, you're using the car, but then if you had to design your own car to drive, it would be disastrous, I suspect, at least for the first couple of cars. So what I've learned is I should have, with hindsight, added an operational amplifier, an op-amp, as was suggested some episodes back, a rail-to-rail operational amplifier that never allowed the audio levels to go past whatever gain my amplifier can support. So it would never allow the inputs to overdrive. Thus, the outputs would also never overdrive, and I would guarantee optimal gain conditions. I did not do that. I did not do that. So what was happening was these guys, these digital analog these potentiometers were getting overdriven. They were causing all kinds of different audio distortion, which in an audio amplifier, audio distortion for listening is not good. Like if it's a guitar amp, yeah, that's awesome. This wasn't the good audio distortion, though. This was a bad audio distortion. So what I have used, all that to say, I did not do the op amp. In Mark II, I would definitely do a preamplifier op amp section that is controlled by a digital potentiometer, which would guarantee perfect levels. And in test equipment, I believe that is what is done. And a lot of equipment, that's what is done. I just have a potentiometer here that's just trying to knock down the voltage levels and control it with a very basic volume control. So I used two DS1841 modules. If I find them, let's see, they're the Adafruit. Here, you guys can follow along. They're the Adafruit DS1841 I2C 10K potentiometers. So two of them, $5.95, $5.95 each. So that's what I paid, $5.95. Plus I think it was like $4 shipping. I used two. It ends up the potentiometers are, wow, the second most expensive thing on my whole board, I think. Let's see, potentiometers is $5.95. Let's say it was $4 to ship them, so that's $2 each. So we will say $7.95. $7.95 times 2. But the real reason why I switched back to these potentiometers and away from the other audio potentiometer is this guy has a built-in series resistance of 3K, 3.7K in fact, and it doesn't allow the signal to get overdriven, and it just sounds better. It just sounds better. I mean, that is qualitative and not quantitative, but when I plug it in, and this is, if you go and buy a really high-end amplifier, one of the things that you should do is spend some time listening to it, because if you're going to drop a lot of money on a thing that you're planning on listening to a lot, it should sound perfect. And this just sounds better. It just sounds better. So that was the real reason why I switched back to these two potentiometers. Is that everything in the box? I think that is just about everything in the box. I mean, I have some connectors over here in the back, and I have a connector right here. These are all a couple of dollars each. I'm not going to get too wound up about that, unless I get kind of close to being what it costs to build a Sonos amplifier. But if I am not close, I won't worry about it. But let's go over and see if I can make a real quick spreadsheet. And then, you know what, we'll do just a quick listen here. Let me see if I can just get into a quick spreadsheet. I think I can. I think I can. I think I can. I think I can. Go to the spreadsheet. Let's make a new spreadsheet. Kids, this is going to be your life. This is your life. Okay, power supply. I probably should have just been typing this in the whole time. Power supply is 2574, 2574, 74. Then the Raspberry Pi is $36.95. The TPA 3116D2 is $8.55. The PCM 5102 is $3.91. That is my DAC. The DC to DC converters are $1.59, $1.40, and then the real splashy $3.25. The switchboard for the audio was $3.45. How are they sending stuff all the way from China all the way back to America for $1? That's crazy. Relay. That thing had $1 shipping on it. It went by planes, trains, and automobiles and managed to make it all the way back here. So $3.95. And then my potentiometer is $7.95 plus another $7.95. Oh, I almost forgot. I mean, a pretty big part of this build is the box. I mean, the actual box it's in. How much did the box cost? I can't remember. Let me see if I can look that up real quick, because I mean, it's as far as size of components go, it's pretty cool. It's pretty cool. Get the box back on there. If I bring this up. Come on, guys. That's cool, right? That's cool. How much did the box cost? Let me see if I can find it. I bought this box on Amazon because my box making skills are terrible. Have you guys ever tried to make just a box? I mean, you can make a real basic box easily. To make a precisely connected box that has smooth edges and right angles is a little bit more tricky. It's a little bit more tricky than I would have thought. Oh, I also forgot the NeoPixel. The NeoPixel and the NeoPixel, let's see, it was $6.50. That is the LED ring. Gotta write that down. $6.50. And the rotary encoder. Oh my goodness. I almost forgot the rotary encoder, which is a pretty big deal. Rotary encoder was, I think I actually have it, $4.88, which is actually a pretty bad price for that rotary encoder. But you know what? I didn't know any better. Bought it, splashed out. The box does look like it contains magic. I agree. I was thrilled with how this turned out. Mrs. Oscope Wizard helped quite a bit. She has a vinyl cutter and was able to cut out a stencil for me, and then I spray painted it on and pulled the stencil off and got the negative, and it looked pretty sharp. I thought. Okay, so the box was $4.77. An unfinished wooden box for craft or jewelry. Did I say $4.77? $14.77. Okay, so those are the big components. Now, here we go. What are we gonna do? We're gonna do equal sum of all of this. How much do we roughly spend? $130.84. That's pretty good. That's pretty good, man. So that means this box, which gives me that sweet, sweet sound and has some real panache, I think, costs about $1 or about $130.84. Custom made. The question that just came in the chat, did I video any of the paint stencil process? I did video it, and I will have that in kind of my summation video that'll be a little bit, poppy. I don't know if you guys watch a bunch of these how to make this thing videos on YouTube, but I watch a ton of them, and and I hope I can recreate some of that video style. And then, what is your hourly rate? Wow, I've noticed that no DIYers include an hourly rate, but wow, this box would be so expensive if you included, like, even if we just said, like, how many hours we spent just together on the live stream. It's like 2 hour or 1 hour a week for 9 weeks. And let's say I got paid $15 an hour. Let's say 10 weeks, and then it'd be another $150 just there if you just accounted for the live stream. But whew, man, that is crazy. Oh, and then subtract the tuition. Oh man, $138. I'm really excited. I'm really proud of what we accomplished here. We made something really cool that works, that we can listen to, and yeah, $130. I mean, a Sonos amplifier. How much a Sonos amplifier? I think costs $600. So we beat our goal of being less expensive than the Sonos amplifier. That's the trick. I guess if we were going to build a car and we're like, I want to make a car that's more affordable, our goal should be like Rolls-Royce. And then if we could make a car anything less than a Rolls-Royce, it would be awesome. I guess I picked the Rolls-Royce of a Rolls-Royce style of audio amplifiers. But let's listen. Let's just listen to something, man. Let's just listen to something. Real quick. I'm going to switch it up to, let's see if I can find it. I don't know if I can. We talked about the Three Owls music the other day, or the band that I was listening to, Hope for a Golden Summer. But I can't even find it now. So we will listen to this other thing on Spotify so we can see the light change colors. Here we go. We're going to connect. We're connected. Let's turn it up a little bit. And we're off. Look at it. I can turn it down. I can turn the volume down. Oh, I love it. I love it. Oh, man. I can't believe we made this. I can't believe that you guys stuck with me and had all these awesome suggestions and that we were able to solve problems. Oh, I really appreciate it. I really appreciate all the help. And I can't wait to start our next quest together to see what we could build. What can we build next? I don't know. There's so many different, the possibilities are literally limitless, only bounded by our imagination. I'm Gabe, the O-Scope Wizard. I don't know all the nerds in the world, but I'd love to meet them. Please share this with a nerd in your life. I'm going to be cranking some tunes and hanging out in the chat, and I will see you guys next week. Thanks so much for hanging out with me. Here we go.
This summer I swam in a public place in a reservoir. At the lighter I was informed.